welcome to this week's Tech Talk. Last time we heard from Natasha and Florian about some of the considerations that an application engineer makes when they are first looking at a part that comes in from a customer. What I'd like to talk about today with our experts Michael and Thomas is what particularly is important when you're developing an application in terms of the parameters inside of our machines. Okay, so the first question I have today for Michael, who's our M expert, is what are the most important parameters that you think about when you're putting together a successful build file for our metal machines?
I would say it's 4 different ones. It's the laser power, it's the scan speed, the hatch distance, and the layer thickness.
And what exactly is the hatch distance?
It's the distance between 2 adjacent scan vectors.
Okay, and is it about the same in Polymer, the same importance of the parameters?
Yeah, it's about the same, but we have an additional factor. It's the building temperature. I don't think in metal you don't use the building temperature as a important parameter for the mechanical properties of the parts, but on Polymer side, the building temperature has effects on the surface, on the mechanical properties. Yeah.
So when we're talking about these parameters, for example, if I wanted to change the layer thickness, can I just double the layer thickness and then double the amount of energy that I'm using the laser for? Is that possible?
I mean, it's not that simple. There is no linear connection.
Okay.
But you would need to run the DOE to find out the best combination.
Okay, and I'm assuming probably the same for Polymer.
So basically you can use the standard EOS parameters for the other layer thicknesses, then you know you're safe and you don't have to increase the energy you put into the powder manually.
Okay, so Michael, when we're looking at a part that we're designing for metal, are there any specific geometries or pieces of the part where you would know, for example, that you have to adjust the existing parameters?
Oh yeah, I mean the EOS standard parameter is a compromise between different application and different standards. So necessarily for extreme geometries like lattice for thin-walled parts, they are not the ideal parameters. So it's very beneficial if you adapt them to your application.
And what about on the Polymer side?
We have several parameters to choose, and depending on the geometry of the part, we choose our parameter. For example, if you have holes in the part, you use a different parameter than massive parts. And if you have really massive parts with very thick walls, we have a special parameter that decreases that energy that is put inside of the part. We increase the energy in the, in the border of the part, and inside we reduce it.
Okay, so what about, does the orientation have anything to do with that? Would you ever change the parameters because of the way you orient the part? Are they interconnected at all?
Most of the times it's easier to adjust the orientation, because for the orientation you have a lot of possibilities how to orientate it, and with the parameters you just put, let's say, the cherry on the cake.
And what about on the metal side, Michael? How does orientation kind of play into the way you're developing parameters?
I mean, orientation has a big influence, especially in downskin regions. We have a higher surface roughness, but you also can do a lot with the parameters there. So especially the surface parameters are influencing the part a lot.
Is it better to have less energy or more energy, or is it all dependent on what your application is?
It's depending on the application. In general, for downskin you take less energy. On the other side, for upskin you may take more energy to get a nice smooth surface finish.
Okay, so Thomas, how easy is it, or what kind of time investment is it to really adjust parameters?
In Polymer it's quite an effort to realize new parameters, because the customer gets some standard values from EOS that he can start with. But it's just a start value. He has to adjust the laser power, the hatch distance, scanning speed, and we have different parameters that he can change. For example, the hatch lines, these are the lines which fill out the parts, the contour lines that go around the parts, and the edge lines that are for very thin structures. And he can adjust every single parameter in a way that he wants. He can increase the energy, decrease the energy, increase the speed, decrease the speed. So he has a lot of possibilities, so it's quite an effort to create a new parameter.
And what about on the metal side? Are there quick levers that you can adjust in order to optimize your application?
Yeah, I think in metal it's significantly easier because the default parameters are like the standard parameters that we also use for our benchmark parts. But since they're open, the customer can just take out of the set what he really needs. If he doesn't need contours, then he can just delete the contours. And also he can change individual parameters. And I think that's not that big of an effort.
So parameters are also not just buildability of your application, but also adjusting your parameters can save you time eventually as well, right?
Eventually, yeah.
Yeah, I think especially in metal it's important when you go to a serial production that you adapt the parameters to the specification of your application.
Okay, well thank you Michael and Thomas for joining us, and we'll see you next time here at the Application Tech Talk.